Okay, so what we're going to talk about today is actually writing an equation if you have the picture of the graph. These really are not that difficult. What it boils down to is the amplitude. You're going to need to know the amplitude of the graph, which is the leading coefficient, the A. You're also going to need to know the period of the graph, because if I know the period, I can find the frequency. Keep in mind, the period is equal to 2 pi divided by the frequency. And so if I do a cross product here, I will tell you that the frequency times the period equals 2 pi, which means then that the frequency will be equal to 2 pi divided by the period. So I actually have two formulas now. I can tell you that the period is equal to 2 pi divided by frequency. I can also tell you that frequency is equal to 2 pi divided by the period. So depending on what you know, you can find the missing piece. Now when I look at this graph, first thing I'm going to figure out is what function this is. Because it starts at 0, I know that this is the sine function, because cosine would start high. So when it goes to the origin, that's how I know it's a sine function. I also know that the height of the graph, this amplitude in here, is 2. The distance from the midline, from the axis to the peak, is 2. So I can begin writing my equation right away. Y equals, I know that I have an amplitude of 2. I know that my function is the sine function. Now what I need to know is the frequency. So what I look at is where does the graph end? And this trig function ends at pi. So there's a couple ways to go around this, but probably the safest way is to just use the formula. If I know the period is pi, then I can plug it into this one to find the frequency. You could plug it in over here too, but this one's probably easier. So again, the period from this graph is pi, and I read that from where it ends. So that means that the frequency is equal to 2 pi divided by the period, and when I simplify this, the frequency will be 2. I will transfer that over here as a 2x. And this is the function equation for this particular picture. Okay, let's try another one. Okay, so here we have another example. When I look at this, first thing I do is decide sine or cosine because of the nature of the oscillation. The fact that it does not go through the origin, but that it's starting high on the axis tells me that this is the cosine curve. I have one full cycle of the cosine curve that looks like it's ending at 4 pi. So what I can tell you is that the amplitude is equal to 3 and the period is equal to 4 pi. So knowing that, the frequency then is 2 pi divided by the period, and these will cancel and the whole thing reduces to 1/2. Once you have your amplitude and your frequency, we can simply place it into our equation. Amplitude's 3. Again, it's a cosine curve with a frequency of 1/2 x. We could put that in parentheses. Okay, so this one's a little different. Again, first thing I want to do is figure out what function I'm talking about. The fact that, again, does not go through the origin says this is not the sine function. Cosine typically starts high, but this one is starting low. This one is upside down, which means there's been a reflection in the x-axis. So I know I'm going to need a negative. I also notice that this is not evenly spaced around that axis or that midline, which lets me understand that there has been a vertical shift. So what we want to do is find the distance between these. We want to find the midpoint between 1 and -3. So if I draw in my new midline, which is right there, this happens to be at y equals 1 right here, because this is going to be 2 units below, and then this will be 2 units above. So if this line right here is at y equals 1, I know then that I have a vertical shift of +1. My amplitude goes from the midline to the peak. And the difference, of course, between 1 and 3 is 2. So, and I kind of knew that from here, but it might be easier to see on the picture. So I know then that my amplitude is equal to 2. I know it's been reflected. It's because it's upside down, so I have to watch for the negative. I know that it's a cosine graph. Now, as far as the period goes, this graph ends at pi over 2. That means then that the frequency is 2 pi divided by pi over 2, which is the same as 2 pi times 2 over pi, because remember you multiply by the reciprocal. The pi's cancel, leaves me with a frequency of 4. Putting it all together, y equals the negative of 2, that's my amplitude, cosine of 4x and a vertical shift of plus 1. And there is my equation. So here's an interesting one. And there's actually a couple ways that I can do this graph, believe it or not. Because when I look at this, notice this is one full sine curve. And I notice that this is one full sine curve because it starts on the origin. Normally sine starts, or not the origin, but on the x-axis. Normally a sine starts here at the origin, whereas this one is crossing the y-axis up here at 4. So I'm going to actually write this for you as a sine graph and as a cosine graph. Okay, so just so you realize that you could do either one. And if you want to check those on your calculator later, you can do that just to verify that it really is the same graph. Okay, let's do the sine graph first. Okay, so y equals, and I'm going to have a sine. Now, as far as the amplitude, this is 4. So my amplitude is 4. Frequency. Frequency comes from the period. This is where you got to be careful, because part of this graph is to the left of the axis and the rest of it is to the right. So you cannot just look here and say, oh, the period's 3 pi over 2, because the full cycle has 3 pi over 2 here and another pi over 2 here. When you put those all together, you get a period of 2 pi. Okay, 90 degrees is on this side, 270 degrees is on this side. But together, you get the full 2 pi. So if the period is 2 pi, that means the frequency is 1. So my equation will just be 4 sine of x. Ah, but wait, because sine typically starts at the origin. And so how did we get it over here to start at negative pi over 2? Well, that's going to be a phase shift. And the way that I will shift it to the left, pi over 2, is to simply add pi over 2 to the x value, the angle. Because remember, you always go the opposite of what it looks like here. So x plus pi over 2 means pi over 2 to the left. Okay, so this would be the function equation as written as a sine function. If I wanted to write this as a cosine function, here's the thing. The amplitude stays the same. The function is going to be different. The frequency and period are still the same. But here's what I want you to realize. If I were to cross this part off and shift it, or cut it, I should say, and shift it over to here, I would simply have, so again, if this is gone, I simply have now from here to here one full cosine curve, one full period. And that 90 degrees would tack on here, and I would get my 2 pi. That is the cosine curve. So this would be the function equation for cosine. Keep in mind, I've told you before, if you take the sine graph and shift it to the left 90 degrees, you end up with the cosine graph. In fact, that it's still one period, even if it's not the typical cosine period, okay? So cosine we like to see start high and end high, but this graph, I can take any window I want of this graph and it will still be the same equation. Okay, this one's a little different. When I look at it, first thing I notice is it's not a full graph. That's first. Secondly, when I look at this, I realize that it starts high, so it's not going through the origin. It's not starting on the x-axis, which tells me it's most likely not going to be sine. So I'm going to start it as a cosine graph. But what I'm noticing is that I'm only going to see half of the graph. Now, I want to know what the period is. That means I need to finish this graph. I need to finish it so that I can tell you where it ends. Only seeing half of a graph is not a full period. Now, 3 pi over 2 is 270 degrees. That's a bizarre mark. But let's cut that in half to get this, because that's what's going to help me find that period. Okay? So what I want to do is take my 3 pi over 2, and when I cut it in half or multiply it by 1/2, I will get 3 pi over 4. Now, you know what? That makes sense, because 3 pi over 2 is 270 degrees. So half of that would be 135 degrees. Now, I can either multiply this by 4, or actually I could have multiplied that by 2. Either way, if half of the graph is at 270, then the full graph will end at 540, and then I could just change 540 into radians by multiplying by pi and dividing by 180 and figuring out what that would be, which would be actually, 3 pi. Okay, now, the other way to do this, again, is to figure out what this one mark is here. So this one here would be 3 pi over 4, because that's a fourth of the way through. Then I would need 2 more of those marks. So if this one is 3 pi over 4, this would be 6 pi over 4, which is why it's reduced. This one would be 9 pi over 4, and this one would be 12 pi over 4. And 12 pi over 4, again, would simplify to 3 pi. So once I know what my period is, and I gave you 2 different ways to do that, probably even more than that, once you know that your period is 3 pi, and we know that our frequency is going to come from period, our amplitude is 2, and that's an easy one. There doesn't seem to be any other shifts, so I can go in and find my frequency. Remember, frequency is 2 pi divided by the period, which is 3 pi. So my frequency is going to be 2/3. Now, y equals 2 cos 2/3 x. Okay, that one was a little bizarre because of the fraction. Interesting fraction. Okay, I have one here. I'm going to have you try. So pause, go through the same steps that I went through, pause the video, figure out your amplitude, your frequency, what function is it, if there's any shifts. I think you can clearly see that there's a shift on this one. And write down your function, and then when you come back, we'll see if you have completed it correctly. Okay, let's see how you did. First off, I decided it was a sine graph because it starts here at the midline. First thing I actually did was find the midline. So halfway between 3 and 6 is 4.5. You could either split the difference and cut it in half, or you can take the average of 3 and 6, which add them together, you get 9, divided by 2, it's 4 and 5, 4.5. So the midline of the graph runs right here. This is my new axis. The way to get there is to vertically shift up 4.5. So over here I've written that down. The next thing I find is my amplitude. From midline to peak is 1.5, so my amplitude is 1.5. My period is here at pi over 3, which allows me then to find my frequency. So instead of dividing by pi over 3, I'm going to multiply by 3 over pi. I get 6. So I have my frequency, I have my vertical shift, I have my amplitude. The other thing I need to know is that it's the sine curve. Because this starts at the midline, which would be like my new origin, I know this is sine, but the fact that it's going down first says there's going to be a negative in front. So when I look here, y equals a negative of 1.5, my amplitude, sine, 6x, because I decided my frequency was 6, plus 4.5, because that's my vertical shift. Hopefully you got that. Okay, so we're going to look at these a little bit closer tomorrow. A little bit different kinds of problems also. So just keep that in mind. Thank you. See you in the morning.